When you think about how we make steel, what comes to mind? Probably those giant, classic blast furnaces, right? Well, today, the real workhorse, the unsung hero of the industry, is actually this high-tech recycling machine. We're talking about the electric arc furnace. And as you're about to see, its secret to success is all about having the perfect recipe.
That's right. It might surprise you, but it's the electric arc furnace, or EAF for short, that's become the #1 way we make steel here in the United States. It's this quiet revolution that's been all about efficiency and, you guessed it, recycling. So how does this thing even work? Well, imagine taking the power of a lightning bolt and putting it in a box. An EAF uses these massive graphite electrodes to create an electric arc that's hotter than 3,000 degrees Celsius. It's just an insane amount of energy that melts down tons of scrap metal, old cars, appliances, you name it, and turns it into brand new high-quality steel.
But here's the catch. As incredible as this machine is, it has one fundamental weakness. The final steel is only as good as what you put into it. It's the classic garbage in, garbage out problem. And that brings us to the big question we're tackling today. What is the perfect recipe for making modern steel?
To figure that out, we've got to start with the EAF's biggest headache, this constant battle it fights against impurities.
And the main villains in this story have a great name: tramp elements. We're talking about things like copper from old wiring or tin from cans. What makes them so tricky is that, unlike other junk, they don't burn off or get removed in the furnace. They just hang around in the final product, making the steel weaker and less reliable.
And wow, this table really shows you the scale of the problem. Just look at the difference. On the super clean end, you have something like sponge iron with almost zero tramp elements, just 0.02%. But then look at the other end. Common stuff like shredded cars can have over 0.5%. That might not sound like a lot, but in the world of high-performance steel, that is a massive, massive difference.
So this all leads us to the furnaces menu. What ingredients can a steelmaker actually choose from to feed this thing?
Well, the choices really fall into two big categories. On one side, you've got the recycled champion, good old steel scrap. It's the heart and soul of the EAF. The problem? Its purity is all over the place. And on the other side, you've got the virgin challengers, made directly from iron ore. Their purity isn't just high, it's consistent and certified.
Let's dig into scrap for a second. It's cheap, it's everywhere, and it's the absolute king of recycling. I mean, it's the backbone of the circular economy for steel. But like we said, its chemistry is a total wild card. It's where most of those pesky tramp elements come from, and it can also trap nitrogen, which is another big no-no for quality.
So, what's the clean alternative? It's something called direct reduced iron, or DRI. This is pure virgin iron, made from ore, but without using a blast furnace. And to make it easy to ship around the world, it's often compacted into these little bricks called hot briquetted iron, or HBI. You can just think of HBI as a super pure, super dense iron nugget.
And the benefits here are pretty clear. DRI and HBI come with a birth certificate, basically, a guaranteed chemical analysis, so you know exactly what you're getting. They're incredibly low in tramp elements, which means you can use them to dilute all the junk in the lower quality scrap. Plus, and this is a big one for business, their price is way more stable than the crazy, volatile scrap market.
So is it scrap versus virgin iron? It turns out that's not really the right question. The real magic isn't in choosing one or the other. It's about creating the perfect blend. And that brings us to what's called the smart charge solution.
See, the best steelmakers these days operate less like furnace operators and more like master chefs. They don't just dump stuff in. They create a precise recipe, a carefully calculated mix of different ingredients to get the perfect balance of cost, quality, and efficiency every single time.
A typical recipe might look something like this. Maybe you use 60% scrap because it's economical, then you blend in 30% of that super clean DRI or HBI to bring the impurity level down, and maybe you add a little pig iron for extra carbon. The point is, every single grade of steel has its own unique secret recipe.
And the smart charge practice isn't guesswork, it's a science. First, you define exactly what you need in the final steel. Then, you analyze everything you have on hand, every pile of scrap, every batch of HBI. Powerful computer models then calculate the perfect mix to hit your quality targets at the lowest possible cost. And finally, automated systems add the ingredients with incredible precision.
Okay, so all this careful planning and precision sounds great, but what's the actual reward? Well, the payoff is huge, and it hits the three things that matter most in steelmaking:
energy, yield, and, of course, cleanliness. Let's start with energy, which is just a massive cost. This table shows just how much that recipe matters. A furnace running on 100% scrap uses about 450 kilowatt-hours for every ton of steel. But look down at the bottom. If a mill can mix in hot liquid iron, they can slash that energy use all the way down to 280. Your recipe directly controls your power bill.
But it's not just about energy savings. There's this amazing chemical benefit too. The carbon in materials like HBI create something called a carbon boil when it melts. Seriously, think of it like a pot of water boiling on the stove. That bubbling action acts like a natural purifier. It literally scrubs unwanted gases like hydrogen and nitrogen out of the liquid steel.
And the results of that purification are pretty stunning. Steel made from 100% scrap might have up to 100 parts per million of nitrogen. But look what happens when you use 100% HBI. You can get the nitrogen level down to as low as 15 ppm. That's actually cleaner than steel made the old-fashioned blast furnace way. It proves that an EAF, with the right diet, can make some of the highest quality steel on the planet.
And this chart brings it all back to our old enemies, the tramp elements. It shows you the dilution effect perfectly. You start on the left with 100% scrap and high levels of residuals. But as you start blending in more and more clean DRI, you just systematically push those impurity levels down, giving you total control over the final quality. So, this smart charge strategy is already transforming the industry. And the future? It's all about pushing that precision even further with cutting-edge technology and automation.
And we're seeing some seriously cool tech coming online. You have systems that offer incredibly fine control over the melting process. You have others that completely automate charging the furnace. And you have these powerful AI models that crunch real-time data to find the absolute perfect recipe for every single batch on the fly.
So the takeaway here is pretty clear. A smart charge practice isn't just some nice-to-have idea. It's absolutely fundamental. It's this combination of a smart raw material strategy and the power of automation that's paving the way for consistent performance and a truly sustainable future for steel.
Which leaves us with one final big question to chew on. The EAF is the ultimate recycling machine, but to get the best performance, it often needs a dash of brand new virgin material. So as we push for greener and greener steel, is the future going to be built on what we recycle or on what we create anew? That's really the core puzzle at the heart of modern steelmaking.